In this problem, we're looking at the time it takes a jogger to run 1 mile. So in minutes is a function of the number of weeks. There's our input. So we have output is the minutes it takes. Input is the number of weeks. So output is minutes to run 1 mile. And input is the week number. So the weeks that you've been training for. So in letter A, to identify the rate of change, well, we notice that that's the negative 0.2, and its units are going to be units of output divided by units of input. Now remember, you can think about this as being over 1. So this is going to be minutes over weeks. So what's happening here? Well, there's a drop of 0.2 minutes each week. And we should probably say on average, because we don't know that this runner is actually decreasing the total running time by 0.2 every week, but that's the average rate of change. So here we have negative 0.2 minutes divided by 1 week. In letter B, we want to find the vertical intercept, which again is of the form 0, something. So t of 0 would be negative 0.2 times 0 plus 8.1, or we recognize that that's just going to be the constant value. The starting value is 8.1. So what could we say? Well, the input is 0, so this represents weeks, and this represents time. So we could say that week 0, it took 8.1 minutes to run a mile. Similarly, for the horizontal intercept, we want to know a point of the form something, 0. And in this case, we're going to let the output be 0. So we'll have 0 equals negative 0.2 w plus 8.1. We subtract 8.1 equals negative 0.2 w. And we divide by negative 0.2. So we get negative 8.1 divided by negative 0.2. Is going to be 40.5, and that equals W. So what did we just say here? We just found out that the week is 40.5 and the time will be 0. So are we saying that it will take 0 minutes to run the mile after 40 weeks of training? Well, I think we are saying that, but that's with the assumption that we're continuously, from a starting point of 8.1 as a time, that this is continuously dropping, and eventually after 40.5, mathematically, we'll reach a point where the total time is 0. Now this practically probably doesn't make too much sense, and so we should probably ignore the meaning of the horizontal intercept.